Hi everyone, welcome back. And today we are doing this question called maximum number of vowels in a substring of given length. So we did a similar question previously. It was like finding the maximum average of a substring, but I'll just go through this question and address how to do a walkthrough, do a quick walkthrough. Even though this question is rated medium, I would say this is one of the easier mediums that is out there. So let's get to the question. So given a string s and an integer k, return the maximum number of vowel letters in any substring of s with length k. So if the k is 3, we just look at 3, a substring of size 3 at every time. So like this, and like this, and like this. And out of that, different options for 3 length strings, we are trying to find how many vowels are inside, and we need to return the maximum number of vowels in a list in a substring that is of length 3. So the maximum that you can get is 3. So yeah, we just need to find a way to iterate through to see all the combinations and see what would give us the maximum number of vowels. So to do that, to my knowledge, in Python string, there's no shortcut to this. We just have to find a way to get the vowels. Like, so what I'll be using is I'll be creating a set, which is like a uh, hash map like item, hash set like item, and it will access the vowels in constant time complexity. So that's the benefit of having a set. But since the list itself is so tiny, you won't be sacrificing much of time complexity if it's like a true like an array instead of a set. So I'm opting for a set over here, but it's okay if you go for something else. So the logic that I'm going to employ is I'll first traverse through the first 3 items in the list, which because it's k is equal to 3, I'll look at the first 3. And then I'll count the vowels and I'll keep this separately. And subsequently, what I'll do is I'll employ this technique that we discuss quite often in this channel, which is sliding window. So this is, once again, a very useful technique. Knowing how to apply it properly, knowing when to apply it properly might save a lot of time and complexity in coding. So yeah, so first thing that I'm going to do is find the first 3, and after that, use a sliding window to check the previous one and the next one. So that way, I will drop the previous one in these 3. I'll drop the previous one, I'll be left with BC, and I'll add the next one, which is I. And as I'm dropping and adding, I will verify if the one that I'm dropping is a vowel and the one that I'm adding is a vowel. And that way I get to have a running sum of the number of vowels, and that kind of helps us identify the maximum number of vowels that we need. So maybe I'm over explaining this, but I'm just running through the whole thing. Yeah, so I'll get straight to coding. So the first thing that I'll be doing is I'll just isolate and look at the first 3 letters. So for I in range K, I will look at it and say if uh, the item is in vowel. Okay, there's no is logic. If the item is in vowel, we have to increase the vowel count by 1. So instantiate a vowel counter. We're creating a variable called count. And yeah, so this should work. We will get the count of vowels. And subsequently, what we need to do is we need to build the sliding window function. So once again, for I in range length s minus k, we will do something. Okay, let me erase this. Okay. We will have a itemized like we will just itemize it first because I don't want to use the indexing method for every step. So first and second letter. The first letter will be this, and the last item will be. So in this example of 3, the first letter will be A, and the last letter will be I. This thing. So I will SI and SI plus K. So since K is 3, when I is equal to 0, it will refer to this. And when 0 plus 3 is 3, so it will be 0, 1, 2, 3, it will refer to this. So first will be A and last will be I, as mentioned earlier. So what am I trying to do now? So if first is in vowel, I need to reduce it from the count. So count minus equals to 1. And I can't do an else if because I need to check both. If the last item is in vowel, I need to add it. That way, this way we are checking if the last item is in and the first item is in as well. So first and last. And so with this, we get the running sum, the running net sum of the new vowel. Like over here, we lost a vowel, but then we added another vowel. So the running sum is still 1, and so on and so forth. But we want to keep track and find the maximum. So for that, we need to create another variable earlier on, and it will do something like this. And the max should be, so after we find the initial 3's number of sums, we put that into max as the initial value. And after sliding to the next 3, we see if the present count is larger than the existing maximum value. And if it is, it will just update the max value. So with that, I think we should be done with it. We could just return the maximum value, and that would be the answer. So let's run this. Okay, so it works in this case. It works in this case, even though there's like all of them are vowels, k is equal to 2, so the maximum value that it can return is 2. So yeah, maybe if I want to trim this even faster, I can do something like this. If count, if at any point if count is equal to k, if count, should I do it after before? Yeah, if count is equal to k, we can just return k. This is an early termination to like maybe make it faster. But basically, since k is equal to 2, the maximum value that it can be is 2. And the second count reaches 2 at any point, like maybe it reached 2 here itself, the first 3 itself brought its maximum value. So if count is equal to k, we just return k. And that is an early termination technique. So the first technique that we talked about was sliding window. This is the next technique, which is early termination. So yeah, this is optional. I think it'll still work without this, but in the event we have like millions of items, like they do say like 10 to the power 5. So if it is that big, an early termination kind of function will prevent it from going through the entire for loop and terminate early, somewhere in the middle, if we have seen the highest value possible already. So yeah, that is my solution. Let's just make sure it runs across all the solutions as well. So yeah, this beats 88% of all Python users and 96% of all Python users in terms of memory. So I'll just break it down quickly, like how and what we're achieving. So in terms of time complexity, this does nothing, this does nothing. This is of k time complexity, and this is n minus k of time complexity. And the net sum of this will just be n time complexity. And that's for time. As for space, we are creating a new object, like a data object, which is a set, but it's constant because no matter how big or how small the numbers are, it will always be just length 7. So This is constant time complexity, space complexity over here. And as for the rest, we are not seeing any new array creation, so it should be still stable. So yeah, this is probably the most efficient, but I mean, there's probably other solutions that I don't know yet. So if any of you has any feedback, do let me know. And I'm always looking to learn to improve myself as well. So hope you guys enjoyed this video, and I'll see you guys in the next video. Bye.